Hi, this is Rob Yates, and this is the video for Lesson 3 of Algebra 1. If your teacher is Ms. Boatwright, Ms. Reynolds, Mr. McCrae, Mr. Still, Mr. Strickland, or Mr. Yates, you're in the right place. This is Lesson 3 of Week 1. Our learning target today is I can determine if a table or graph is linear, exponential, or quadratic. What we have here is a little bit of review about quadratics. In the lower left-hand corner, we have 4 examples of parabolas, or the U-shaped graph that is characteristic of a quadratic equation. Although it hasn't registered well over here on my top left-hand side, what this says basically is quadratic equations are in the form of y equals ax squared plus bx plus c. But mostly it says we just look for an equation with x squared. And to point that out to us, they have given us a table and the graph of the equation y equals x squared. We can see that 2 times 2 equals 4, negative 2 times negative 2 equals 4, negative 1 times negative 1 equals 1, 0 times 0 is obviously 0, 1 times 1 is 1, and 2 times 2 is 4. This particular slice of the table is important because it shows us the vertex or the very point of the parabola, whether it's the very bottom or the very top. In this case, it's the very bottom. Here we have linear, exponential, and quadratic graphs, and it wants us to label each one as we identify them. Top left-hand side with a red line, we see a straight line, which is a dead giveaway. That adds a constant amount each time, so it is going to be linear. Top right-hand side, blue line, pretty much the same thing. It's a different angle, obviously different y-intercept, but it's a straight line and it goes up at a constant amount. It's linear. Lower left-hand side, we have a U-shaped graph, as you can see right here. U-shaped graphs, what does that mean? It means it's quadratic. And the final graph, which is purple, shows us a line that starts to increase very slowly at first, then faster and faster. Well, that is a characteristic of an exponential graph. How do I identify a quadratic from a table? Well, take a look here. We can see from this table that 0 plus 1 is 1, and 1 plus 3 is 4. 4 plus 5 equals 9, and 9 plus 7 equals 16. So it's not linear, right? But let's take a closer look at what they call the second difference. 1 plus 2 does equal 3, and 3 plus 2 does equal 5. 5 plus 2 equals 7. This second difference is uniform, therefore this is the table of a quadratic equation. If the second difference is the same, we know the relationship is quadratic. All right, they want us to identify these tables as linear, exponential, or quadratic. Let's take a look at the first table. 2 minus 2 is 0, which minus 2 is negative 2, which minus 2 is negative 4, so this first one is linear. All right, let's take a look at the next one. 4 plus 3 is 7. 7 plus 5 is 12. And 12 plus 7 is 19. So that is not a linear graph, but let's take a look at the second difference. 3 plus what equals 5? If you said 2, you're correct. 5 plus what equals 7? If you said 2, again, you're ahead of me. So this is a table for a quadratic equation because the second difference is the same. All right, let's take a look at the third one. If I look at this, I can see that 1 times 3 is 3, which times 3 is 9, which times 3 is 27. It's multiplying by 3 each time, multiplying by the same number, which we know means it is exponential. All right, how about the last table? -3 plus 2 is -1, but -1 plus 6 is 5, and 5 plus 10 is 15. So it's not linear, obviously. It's not multiplying. Let's look at the second difference. 2 plus what equals 6? If you said 4, you are correct. 6 plus what equals 10? So if the second difference is uniform and it's 4, what does that make it? If you said quadratic, you are correct. Second difference being the same number, same value, means that it is a quadratic equation. Here's our summary. How do I know a pattern is quadratic? I know a pattern is quadratic if the what difference is the same. If you said second, you are correct. What next? Log into Khan Academy, do an exercise. Go to student.desmos.com, log in with your class code and get started. Try practice worksheet 3 or try Google Homework 3. Remember, you need to do at least 3 assignments each week. Inasmuch as we are at the end of our video, here's a question for you. Why couldn't a leopard play hide and seek? Because he was always spotted. Thanks for watching. We'll see you again next time. Have a great day.